Hi all. So welcome to today's class. Today we are going to see the principles of food process engineering. So this is the part 2. If you have not watched the part 1 video, do watch and then we will be able to understand the second part of principles of food process engineering. Now, yeah, so here we are going to learn about surface activity. So what do you mean by surface activity? It is nothing but certain solid substances will possess a property to influence the surface tension of liquids. Okay, here we talk about two or more immiscible components. So when there are two or more immiscible components, we'll have two kind of phases. One is the dispersed phase, that is nothing but the one containing small droplets or particles, and the other one is a continuous phase. So that is nothing but the phase in which the droplets or particles are distributed. Okay, we need to be very clear about the dispersed phase as well as the continuous phase. Now, so here we have certain examples. You may get this as an question in the food safety officer examination. As we all said, as I already said, this is one of the major topic in processing covered under the syllabus of the food safety officer. So we'll just cover the 1 mark questions too. Here for the dispersed phase, when the dispersed phase is liquid and the continuous phase is gas, we go for example we'll go for the sprays or the spray drying items. So when it is solid in gas, it is like whipped cream, aeration of fermentation media, hydrogenation of oils, and when it comes to liquid in liquid, it is cream, mayonnaise, low-fat spreads, salad, cream, sausage meat, and cakes. And when it is solid in liquid, it's like the chocolate drinks, the fruit juice, and when we talk about, and finally, when it is gas in solid, it is nothing but the meringue and ice cream. Now we are going to learn about the second, like it's not a major topic, it comes under the surface activity. The two important things that comes under surface activity is emulsion and foam. So when we talk about emulsion, as we already said, it is mainly depending, okay, it's mainly depending on the immiscible liquids, okay. Here we need to be very careful about which phase it belongs to, what is the dispersed phase and what is the continuous phase. Emulsions are liquid in liquid phase separation, okay, they owe to liquid in liquid phase separation. Okay, this is a 1 mark, just note down. And now, chemicals that reduce the surface tension in the surface of liquid are termed surface active and are known as surfactants, okay, or they are also called as emulsifying agents or detergents, okay. This is also another 1 mark question. Dash are the chemicals that reduce the surface tension in the surface of a liquid. So they are either surfactants or emulsifying agents or detergents. Now, when we talk about emulsion, there are two important types, okay. One is the natural emulsion and the other one is the artificial emulsion. So when you take any kind of food safety officer question paper, you would get this question, like lecithin. It is a natural emulsifying agent and it is mainly present in egg yolk, okay. Its concentration is really high in egg yolk and comparatively high in soya beans. So what about the artificial emulsion? Artificial emulsion is nothing but polysorbates. It's one kind of an example, and it is mainly used in the food processing industry. Now, I already said we've got another main topic like the foams. Here the foams, the foams phase system is a two-phase system where we have the gas dispersed either in a liquid or in a solid. Okay, to stabilize a foam, like we usually stabilize the foam in the food industry, okay. So it can be either done by freezing. When a foam is stabilized by freezing, we get ice cream, or when it is stabilized by gelation, we get, okay, it's like, for example, we do it while setting a gelatin in marshmallow, or when we stabilize the foam by heating. So that process is applicable while making cakes. There is another way of stabilizing the foams also. Here we would add the protein or the gums. And that's all with the foams, I suppose. Now, what is rheology? Rheology is nothing but a science of deformation of objects under the influences of applied forces. So why do we want to study about the deformation of objects is that to study the texture of a particular food object. So it can be either adhesiveness, gumminess, chewiness, or any kind of textural property. To study that, to study the textural property of a particular food, we need to be knowing it's like we need that term, that science is regarded as rheology. So rheology is nothing but a science of deformation of object under the influence of applied forces. So what happens is that when a material is stressed, it usually deforms, and what happens is the rate and the type of deformation, so that characterize the rheological properties. Here, this is again an important 1-mark question, just jot it down. Quantitative descriptive analysis, QDA. It can either come as an abbreviation question, or they can ask what it does. It is actually the textural, it is a study or the analysis of the textural characteristics. Now, to study or measure the dough structure or the dough texture or the viscosity of starch paste, we use Brabender system. This is again a 1-mark question, jot it down. And to measure the yield stress of any kind of spreads, or to measure the hardness of fruits, we use a cone or a rod penetrometer. Now, the texturometer stimulates the mastication, by compressing food. It has a plunger and it uses a plunger to compress the food, and this would give the property like what when we masticate, where this stimulates, this is somewhat similar to the mastication process. Now, the next property, the next principle in food process engineering is one thing is like material transfer. So this is one of the key factor in solvent extraction or in distillation or in membrane processing. We've learned, that there is a loss of nutrients during blanching. Blanching is nothing but when a produce is subjected to a heat treatment, It is usually done to the fruits or the vegetables, and when the fruits or the vegetables are subjected to heat, there is a loss of nutrients, So this is mainly due to what? The material transfer property. Now, there are two factors that influence the rate of mass transfer. One is nothing but the driving force, which is used to move the materials, and a resistance to their flow. The driving force to move materials and a resistance to their flow. Now, when considering dissolved solids and liquids, the driving force is the difference in the solid's concentration, Whereas for gases and vapors, it is usually the difference in the partial pressure or vapor pressure. So this is one such example. So one example for the material transfer in diffusion of water vapor, is nothing but, so this diffusion of water vapor usually occurs through a boundary layer of air, and this operation is called as the dehydration. The example for such a transfer is called as it's a dehydration or baking. I think you're clear with it. And now moving to the next slide. So water activity is such an important principle of food processing. Now, water activity, it usually deals with the free water in food for the growth of microorganisms. Because why we specifically mention free water is that there are two types, one is the bound and the other one is the free moisture. Because there are two types of moisture, free moisture and bound moisture. Now, This free moisture is usually they entertain the growth of microorganisms. Now, so water in food which is not bound to food particles, or the food molecules, can support the growth of bacteria, yeast and mold. Okay, so when the water is not bound to the food molecules, or it clearly states the free moisture, this free moisture usually supports the growth of bacteria, yeast and molds. Okay, the term water activity refers to this unbound water. Okay, just remember, I already said the water activity usually refers to the unbound water or the free water. Now, water activity of a food is not the same as the moisture content. They are totally different. Okay, the moisture content is usually or it deals with the quantity or how much water it is, whereas water activity, it deals with quality. I'll come again. So moisture content deals with quantity, whereas water activity deals with quality. Water activity is nothing but it is defined as the ratio of the vapor pressure of water in a material to the vapor pressure of pure water at the same temperature. We may get this question. Okay, this is also a 1 mark question. The definition of water activity, or water activity is usually with the free water or unbound water. Okay, and it talks about quality. Some important MCQ in this concept, okay, or under this concept. Now, here are some water activity. Okay, the rate of some numerical values of water activity for some products. Like for fresh meat and fish, it is usually 0.99. For cookies, it is 0.3. For jams and jellies, it is 0.8. For bread, it is 0.95, and so on. Just have a look of it. So we might get this, okay, we might get this as a question in the examination. Next, this water activity, okay, it determines the shelf life because most bacteria do not grow below 0.91. Okay, those include the Clostridium and Botulinum. Okay, so below 0.80, most molds cannot grow, and below 0.60, there is no microbiological growth at all. Okay, so when a food, okay, has such a water activity, uh, uh, when a food, it has a water activity below 0.60, there is no possible causes for microbial growth, but there are chances, okay, for a number of food spoilage to occur. So the microbes that grow within the range, okay, microbes usually grow within the range of 0.8, I think like 0.6 to 0.8. Next, the risk of food poisoning is mostly considered in low acid foods where the pH is greater than 4.5 and a water activity greater than 0.86. Okay, so this Staphylococcus aureus is a common food poisoning organism, and it can grow down to this relatively low water activity level. So this organism, okay, is usually found in cheese and fermented sausages. Okay, so that's all with our principles of food processing. So do like, share and subscribe, and thanks for watching.